aromaticity of organic molecule. Now, just one by one, we will see the different patterns of, or sorry, different factors to discuss the aromaticity. Aromaticity means what? In the old days, the aromaticity was considered as the aromatic compounds which are having a fragrance, that is smell. Any organic compound having a smell, that all organic compounds are called as aromatic. But that concept was not true for all the cases, because some of the organic compounds they show the aromatic characteristics but not having a smell, or some of the organic compound they are having a smell but they are not aromatic. Means the aroma, the word aroma comes from the Latin word smell, but actually at that time the any organic compound having a smell, that type of organic, all organic compounds are considered as a aromatic compound. But this is not true statement, or that theory was not true, which has been proved by the different scientists. Now, exact definition or exact concept of aromaticity is, it is a one type of property which is shown by the conjugated cycloalkene. Means, first of all, I will discuss with you conjugated alkenes means double bond, single bond, again double bond, again single bond. That type of system is called as a conjugated alkenes. Okay, that type of conjugated alkene. And another one is, it must be in the cyclic form. तो कंपाऊंड कसा असला पाहिजे, डबल बॉन्ड, सिंगल बॉन्ड, परत डबल बॉन्ड, परत सिंगल बॉन्ड असा असला पाहिजे, त्याला आपण कॉन्जुगेटेड म्हणतो. तो कंपाऊंड हा सायक्लिक असला पाहिजे, म्हणजे सायकल मध्ये प्रेझेंट असला पाहिजे, जसं की बेंझिन रिंग असला पाहिजे. आणि तो कंपाऊंड मग आपण त्याला एरोमॅटिक कंपाऊंड. And this aromatic compound increases the stability, enhances the stability. Why it enhances the stability? Due to delocalization of electrons, that is pi electrons, or due to pi orbital. That is the unique property. Again, I am repeating the same. Aromaticity is the unique property of the conjugated cycloalkenes, which is present in the aromatic compound, and this aromaticity enhances, increases the stability of the molecule due to the delocalization of electron, that is pi orbital electron. Again, second factor, why benzene is called as aromatic. Aromatic benzene or aromatic molecule, for example, benzene is called as an ideal aromatic compound because benzene is a stable compound, and benzene do not breaks easily, and also they not react with other type of substances. That's why benzene is a highly stable compound which is not converted, which is not breaks down into smaller organic compound. It is a unique property of the benzene molecule, and benzene does not react easily with other type of substances. Means benzene having a spatial stability, and that's why benzene is aromatic. Third factor, the organic compound which are not said to be aromatic because they are called as aliphatic. There are two types of organic compound, aliphatic as well as aromatic. Suppose any organic compound which does not show the aromatic property, and anotherly it is said to be aliphatic organic compound. And aliphatic organic compound might be in the cyclic form or might be in the acyclic form or open chain form. But all the organic compounds have a special kind of stability because they are having a delocalization of pi electron, they are having a conjugated cycloalkene system, and thus they are aromatic. And all the aromatic compounds having a special kind of stability, means they are more stable than the aliphatic compound, as well as they are more stable than the alicyclic type of compounds. Benzene is the ideal compound. Earlier I have discussed with you that benzene is the ideal compound. Why it is called as the ideal? Because because it is possess aromatic characteristics. Benzene and other compounds which are similar to benzene in certain characteristics are called as aromatic compounds. Benzene हा ideal compound आहे, aromatic compound म्हणून. बेन्झीन आणि बेन्झीन सारखे कंपाऊंड्स, बेन्झीन सारखी प्रॉपर्टी दाखवणारे कंपाऊंड्स, त्याला आपण कसले कंपाऊंड म्हणतो, एरोमॅटिक कंपाऊंड्स असं म्हणत असतो. फिजिकल प्रॉपर्टीज some physical properties and some chemical properties which are exactly matches with the properties of that of benzene. That property or collective property is known as aromaticity or aromatic characteristics of the organic compound. Aromaticity means what? Benzene is aromatic compound, for example. Why benzene is aromatic compound? Benzene having a special physical property. Benzene having a special chemical property. Other organic compound which have same physical property to that of benzene, same chemical property to that of benzene, and that's why benzene showing aromatic characteristics, or other compound which have same physical and same chemical property to that of benzene, that type of organic compound called as aromatic organic compound, and the property is known as a aromaticity. बेन्झीन हा aromatic कंपाऊंड आहे. बेन्झीनला काही विशिष्ट फिजिकल प्रॉपर्टीज आहेत, बेन्झीनला काही विशिष्ट केमिकल प्रॉपर्टीज आहेत. ज्या ऑर्गॅनिक कंपाऊंड जे ऑर्गॅनिक कंपाऊंड बेन्झीन सारखे फिजिकल प्रॉपर्टी, बेन्झीन सारख्याच केमिकल प्रॉपर्टीज दाखवतात, त्या ऑर्गॅनिक कंपाऊंडला आपण अरोमॅटिक कंपाऊंड म्हणतो, आणि त्या कॅरेक्टरिस्टिक्सला आपण अरोमॅटिसिटी किंवा अरोमॅटिक कॅरेक्टर असं सुद्धा म्हणत असतो. आता बेन्झीन मध्ये असे कोणते गुणधर्म आहेत, असे कोणते कॅरेक्टरिस्टिक्स आहेत ज्यामुळे बेन्झीनला खास स्टॅबिलिटी आहे? बेन्झीन मध्ये असे कुठले कॅरेक्टरिस्टिक्स आहेत की ज्यामुळे बेन्झीनला आपण अरोमॅटिक म्हणतो? बेन्झीन मध्ये असे कुठले कॅरेक्टरिस्टिक्स आहेत की ज्यामुळे बेन्झीन हायली स्टेबल आहे, पाय पाय डिलोकलायझेशन होतं किंवा सहजासहजी सबस्टिट्यूशन रिएक्शन होते रादर दॅन दी ऍडिशन रिएक्शन? पहिलं बघूया, बेन्झीन हे सायक्लिक आहे. सायक्लिक म्हणजे सायकल मध्ये आहे, बरोबर आहे. त्याचबरोबर बेन्झीन हा प्लेन आहे. प्लेनर बेन्झीन मॉलिक्यूल एकाच प्लेन मध्ये राहतो. बेन्झीन मॉलिक्यूल कम्पेअर केला तर बेन्झीनचा अर्धा भाग ह्या प्लेनच्या वरी, अर्धा भाग खाली असा राहत नाही. बेन्झीन हा एकाच प्लेन मध्ये राहतो. म्हणजे आपण बेन्झीनच्या प्रॉपर्टी बघतोय. पहिली प्रॉपर्टी बेन्झीन सायक्लिक आहे, दुसरी प्रॉपर्टी बेन्झीन प्लेन आहे, तिसरी प्रॉपर्टी फ्लॅट आहे म्हणजे जाड आहे परंतु एकाच प्लेन मध्ये राहतोय. आणि त्याचबरोबर बेन्झीन मध्ये डबल बॉन्ड सिस्टम आहे. डबल बॉन्ड सिस्टम म्हणजे डबल सिंगल डबल सिंगल, त्याला आपण कॉन्जुगेटेड टू अल्टरनेटिव्ह डबल बॉन्ड सिस्टम म्हणतो. हे डबल बॉन्ड हे पाय बॉन्ड आहे. बेन्झीन मध्ये जे डबल बॉन्ड आहेत त्या डबल बॉन्ड मधला एक बॉन्ड हा सिग्मा बॉन्ड आहे, दुसरा पाय आहे. दुसरा सिंगल बॉन्ड तो सिग्मा आहे. दुसरा परत डबल बॉन्ड, डबल बॉन्ड मध्ये एक सिग्मा एक पाय असतो. म्हणजे बेन्झीनची ही एक प्रॉपर्टी आहे की ज्या प्रॉपर्टी मध्ये डबल बॉन्ड आहे, कॉन्जुगेटेड म्हणजे कॉन्जुगेटेडचा अर्थ काय? डबल सिंगल डबल सिंगल, त्याला आपण कॉन्जुगेटेड. म्हणजे बेन्झीन मध्ये काय काय आहे? बेन्झीन सायक्लिक आहे, बेन्झीन प्लेनर आहे, बेन्झीन फ्लॅट आहे, बेन्झीन मध्ये कॉन्जुगेटेड पाय बॉन्ड्स आहेत किंवा कॉन्जुगेटेड डबल बॉन्ड सिस्टम. आता दुसरी कॅरेक्टरिस्टिक बेन्झीनची, पाय बॉन्ड मध्ये डिलोकलायझेशन होतं. बेन्झीन मध्ये असणारे पाय बॉन्ड स्थिर नाही, एका ठिकाणाहून दुसऱ्या ठिकाणी, दुसऱ्याहून तिसऱ्या ठिकाणी कंटिन्युअसली रोटेट होतात. त्या रोटेशनला आपण डिलोकलायझेशन म्हणतो, मूव्हिंग म्हणतो, शिफ्टिंग ऑफ पाय इलेक्ट्रॉन म्हणतो किंवा पाय बॉन्ड. पाय बॉन्ड तयार झाला कशामुळं? पाय इलेक्ट्रॉन मुळे तयार, बरोबर आहे. पाय बॉन्ड शिफ्ट होतो म्हणजेच पाय इलेक्ट्रॉन शिफ्ट होतात फ्रॉम वन पोझिशन टू अनदर पोझिशन, बरोबर आहे. एका ठिकाणाहून दुसऱ्या ठिकाणी पाय बॉन्ड शिफ्ट होतो म्हणजेच पाय इलेक्ट्रॉन शिफ्ट होतात. दुसऱ्या मॉलिक्यूल मध्ये डबल बॉन्ड जरी असला तरी तो एका ठिकाणाहून दुसऱ्या ठिकाणी, दुसऱ्याहून तिसऱ्या ठिकाणी असं कंटिन्युअस शिफ्टिंग होत नाही किंवा डिलोकलायझेशन होत नाही, परंतु होतं कशामध्ये? बेन्झीन मध्येच होतं. त्याला आपण शिफ्टिंग होत असताना, एका ठिकाणाहून दुसऱ्या ठिकाणी, दुसऱ्या ठिकाणी पाय बॉन्डचं शिफ्टिंग होत असताना, पाय इलेक्ट्रॉनचं शिफ्टिंग होत असताना, बेन्झीन जर एकाच प्लेन मध्ये राहत असेल, पाय इलेक्ट्रॉनचं शिफ्टिंग कंटिन्युअस त्या रिंग मध्ये होत असेल तर ते पाय इलेक्ट्रॉनचं जाळं तयार होतं किंवा पाय इलेक्ट्रॉनचा ढग तयार होतो. ढग कसे तयार होतात आकाशामध्ये? तशा प्रकारचं पाय इलेक्ट्रॉनचा क्लाउड तयार होतो किंवा ढग तयार होतात. आता हा बेन्झीन या प्लेन मध्ये जर असेल तर ही कम्प्लिटली बॉन्ड जर फिरत असतील तर ते पाय इलेक्ट्रॉनचा क्लाउड या प्लेनच्या वरच्या बाजूला किंवा पाय इलेक्ट्रॉनचा क्लाउड या प्लेनच्या खालच्या बाजूला तयार होतो. मी आता तुम्हाला फिगर मध्ये दाखवलेलंच आहे. तर हे डिलोकलायझेशन जे होत आहे, from one position to another position, one carbon to another position, there is a shifting of pi electron, thus shifting of pi bond you can call. The due to shifting of pi electron or pi bond, there is a pi electron cloud which is present at the upper side of the plane as well as the lower side of the plane, okay, below and above side of the plane of the molecule. तिसरा आणि सर्वात महत्त्वाचं कॅरेक्टरिस्टिक, बेन्झीन ओबेज हुकेल रूल. व्हॉट इज हुकेल? हुकेलनं काय सांगितलं? हुकेल रूल ओबे करतो म्हणजे काय करतो आपण पुढच्या स्लाइड मध्ये पाहणार आहोत. 4n+2 पाय इलेक्ट्रॉन आहे, ज्याची इंटिजर व्हॅल्यू 0 1 2 3 4 येत असेल तर त्याला हुकेल रूल ओबे करतो असं म्हणतो. तुम्ही तुर्तास हुकेल रूल ओबे करतो. बेंझिन हुकेल रूल ओबे करतो, एवढं लक्षात ठेवा. पुढच्या स्लाइड मध्ये मी तुम्हाला हुकेल रूल डिटेल सांगणार. दुसरी गोष्ट, बेंझिनला हायली स्टेबल आहे बेंझिन, कारण त्याला बेंझिन हा थर्मली स्टेबल असं म्हणलं, कारण मागच्या स्लाइड मध्ये मी दाखवलेलं आहे की बेंझिन हॅव्हिंग अ लो हीट ऑफ हायड्रोजनेशन, हीट ऑफ हायड्रोजनेशन बेंझिनची कमी आहे, किंवा हीट ऑफ कंबक्शन सुद्धा बेंझिनची कमी आहे. सायक्लोहेक्झिन, सायक्लोहेक्झाडाईन, सायक्लोहेक्झाट्राईन या तिन्ही केसमध्ये हीट ऑफ हायड्रोजनेशन मी तुम्हाला शेअर केलेलं आहे. Actually 36 kilocalorie per mole is lesser heat of hydrogenation as compared to trying compound, and that's why benzene having highly stable, because benzene having a low heat of hydrogenation as well as low heat of combustion. Earlier in before two slide I have discussed that slide also in front of you. If one bond is there, how much heat is evolved, two bonds is there, how much heat is evolved. So if you compare the benzene and cyclohexatrine, 36 kilocalorie is the energy lesser which is observed in the heat of hydrogenation. And that's why any organic compound which are having a highly thermal stability or thermally stable, they are having low heat of hydrogenation as well as low heat of combustion. It is the unique property. Benzene shows low heat of hydrogenation as well as low heat of combustion. Next property of benzene, benzene undergoes substitution reaction rather than the addition. Benzene addition reaction देत नाही. बेंझिन ऍडिशन रिएक्शन देत नाही असं नाही. जर तुम्ही टेम्परेचर हाय केलं, जर प्रेशर हाय केलं, म्हणजे नॉर्मल टेम्परेचरला देतो, ड्रास्टिक कंडिशनला बेंझिन ऍडिशन रिएक्शन देतो, परंतु सहजासहजी कोणत्या रिएक्शन देतो बेंझिन? सबस्टिट्यूशन रिएक्शन देतो. हे एक त्याचं युनिक कॅरेक्टरिस्टिक्स आहे किंवा स्पेशल कॅरेक्टरिस्टिक्स आहे. बेंझिन प्रोड्युसेस substitution reaction rather than the addition reaction. Next characteristics, benzene resist to oxidation. बेंझिनचं ऑक्सिडेशन होत नाही. रेजिस्ट म्हणजे तिरस्कार करतं, सहजासहजी ऍक्सेप्ट करत नाही कुणाला? ऑक्सिडेशन रिएक्शनला. कोण? बेंझिन. बेंझिन opposes, resist to the oxidation reaction. For example, oxidation with potassium permanganate or oxidation with nitric acid or other oxidizing agents are there. That's why benzene does not undergoes oxidation reaction. Oxidation reaction, it easily undergoes which reaction? Substitution reaction rather than the addition, rather than the oxidation. Last characteristics of benzene is compound should have diamagnetic susceptibility. Means two electrons are coupled with each other, and the electrons present in the benzene molecule, they are in the diamagnetic form. So this is another characteristics of the benzene molecule. Now I will turn to a very important point, that is Huckel rule. Huckel rule. Erich Huckel in 1931. He is a German scientist which is stated the rule. That rule was described or stated in 1931. He was not a chemist, but he is a physicist. He is a scientist from physics, actually. And he has discovered or noted the rule, that rule called as the Huckel rule. So one by one, I will discuss with you how the Huckel rule is there. To decide the aromaticity, Huckel rule is very important. Either your organic compound is aromatic or not. It is decided only on the basis of, there are so many rules, there are so many, not rules, there are so many factors. Just earlier I have discussed with you that compound must be planar, compound must be flat, compound must be sp2 hybridized, all there should be delocalization must be there, magnetic susceptibility must be there, pi electron must be mobile, that is it should be moves from one position to another position. So these types of conditions are required to show the aromatic compound. But rather than these conditions, one important condition is also there. That condition is known as a Huckel. Compound or organic molecule should possess Huckel rule or should follow Huckel rule. That's why that rule is very popular to decide the aromaticity. Any compound, if it is cyclic, planar, has 4n plus 2 pi electron, it is considered as an aromatic. Any compound. आता कोणताही ऑर्गॅनिक कंपाऊंड जर सायक्लिक असेल, प्लेनार असेल, डिलोकलायझेशन होत असेल आणि आत्ताच चर्चा केलेल्या सर्व प्रॉपर्टीज फॉलो करत असतील आणि 4n+2 जर रूल फॉलो करत असेल, 4n+2 पाय इलेक्ट्रॉन रूल म्हणजे Huckel रूल. आता 4n+2 पाय रूल म्हणजे काय आहे, मी एक्झाम्पल सहित तुम्हाला दाखवतो. जर फॉलो करत असेल तर तो कंपाऊंड अरोमॅटिक कंपाऊंड म्हणायचं. दिस रूल वुड कम टू नो ॲज अ हुकेल रूल. दिस रूल इज नोन ॲज अ हुकेल रूल. आता काय आहे हुकेल रूल? When the number of its pi electron equals to 4n+2, where n is a non-negative integer. Although clear-cut examples are really only established for values n is equal to 0 and up to n is equal to 6. काहीच लक्षात नाही आलं, जस्ट आता पुढे बघूया बेन्झीनच्या एक्झाम्पल मध्ये. लक्षात आलं, बेन्झीनचा एक ब्लॉक दाखवला. ओके, जस्ट यू सी हाऊ 4n+2 और हुकेल रूल इज ओबेड बाय बेन्झीन. बरोबर आहे, बेन्झीन हुकेल रूल फॉलो करतं. का फॉलो करतं आणि कसं फॉलो करतं आपण बघूया. बेन्झीन मध्ये इकडे लक्ष द्या, पाय बॉन्ड किती आहेत? 3. बरोबर आहे. दिस इज 1, दिस इज 2 अँड दिस इज 3. ओके, किती पाय बॉन्ड झाले? 3. एक बॉन्ड 2 इलेक्ट्रॉननी बनलेला असतो. बरोबर आहे, म्हणजे इलेक्ट्रॉन किती झाले? व्हेरी गुड, 6. एक्झाम्पल बेन्झीन, नंबर ऑफ pi bond is equal to 3, right? So number of delocalized pi electrons, 3 into 2, how many electrons? It's very simple, 6 pi electrons are there. Okay, so 4n+2 pi electrons is equal to, correct? बरोबर, ओके ओके, यू ओके ओके, यू दे सरांनी आणलेत का? दे बरं दिला. हो हो, असं. ओके, दिसतात. नंबर ऑफ पाय बॉन्ड्स 3, बरोबर आहे. नंबर ऑफ पाय इलेक्ट्रॉन्स किती झाले? 6. ओके, ओके. नेक्स्ट, 4n+2 pi electrons is equal to, when you put the equation in front, just you put the value of pi electrons. How many pi electrons? 6. The equation will becomes 4n+2 is equal to 6. Very simple. Okay, why then 6? Because 6 electrons are there. If you put 4n+2 is equal to 6, what happens? Therefore 4n is equal to 6 minus 2. Okay, 6 minus 2 is equal to how much? It is 4. Okay, hence 4n is equal to 4. Okay, okay, 4n is equal to 4. The left side of equation is 4n and right side of equation will be 6 minus 2 is equal to 4. Okay, 4n is equal to 4. What about the n? N is equal to 4 divided by 4, n is equal to 1. Now what I am telling regarding the Huckel rule, सायंटिस्ट हुकेलनं काय सांगितलं? n ची व्हॅल्यू निगेटिव्ह यायला नको. काय यायला नको? नो निगेटिव्ह व्हॅल्यू. And the value of n should be integer, not fractional. 1/2, 3/2, 5/2, 2/5. No, no, no. It should be in the round form, not in the fraction form. This is known as a Huckel. Okay, if you calculate the number of pi electron, if you calculate the number of pi electrons, and if you put the value of pi electrons in pi electron value of Huckel rule, that is 4n+2 pi electron, if the equation is solved and the value of n is, yes, non-negative and it should be integer, not a fraction number, then such type of organic compounds are called as aromatic. Okay, are called as aromatic. Huckel rule is very important. So one by one I will discuss with you some examples of Huckel rule here. Uh, Huckel rule for aromatic compound, that is commonly known as the number of pi electrons 4n+2. Just you see the one example, benzene, number of pi electrons are is equal to 6, so n will be 1. Okay. Now another example, pyrrole is there. Okay. Here pi electrons are 6. Now you will confuse with that structure, that how the pi electrons are 6. Okay, now this is a one pi bond, another pi bond is there. Okay, now 2, here 2, how many pi electrons? 4. Now nitrogen having this red colored 2 pi electrons. Okay, are you showing? Okay, connect again. If it is not possible, please here. So these two pi electrons are there. And how many electrons are there? 2 plus 2 plus this nitrogen having 2. How many electrons will be there? 6. Okay. Now this is called as a so thus number of pi electrons are 6. So n is equal to 1. क्वेश्चन असं लक्षात येतो, या रिंग मध्ये दोनच बॉन्ड आहेत, म्हणजे 4 पाय इलेक्ट्रॉन्स आहेत, परंतु हे 2 पाय इलेक्ट्रॉन एरोमॅटिक कॅरेक्टरिस्टिक्स मध्ये भाग घेतात. म्हणजे हे 2 पाय इलेक्ट्रॉन किंवा 2 इलेक्ट्रॉन डबल बॉन्ड फॉर्मेशन साठी उपयोगात आणले जातात, वापरले जातात. म्हणजेच तिथं पाय इलेक्ट्रॉनचा जो क्लाउड तयार होतो, तो पाय इलेक्ट्रॉनचा क्लाउड किती पाय इलेक्ट्रॉनचा तयार होतो? 2 4 अधिक 2 6 चा होतो. म्हणजेच पाय इलेक्ट्रॉनचा क्लाउड फॉर्म होण्यासाठी हे 2 इलेक्ट्रॉन जे नायट्रोजनवर प्रेझेंट आहेत, ते 2 नायट्रोजनवरचे इलेक्ट्रॉन सुद्धा वापरले जातात. त्याला आपण अरोमॅटिक सेक्स्टेट म्हणतो. अरोमॅटिक सेक्स्टेट म्हणजे 6चं जाळं, 6 इलेक्ट्रॉनचं नेटवर्क बनतं, जाळं बनतं किंवा पाय इलेक्ट्रॉनचा क्लाउड बनतो. तो पाय इलेक्ट्रॉनचा क्लाउड म्हणजेच अरोमॅटिक सेक्स्टेट तयार होण्यासाठी नायट्रोजनवर असणारे 2 इलेक्ट्रॉन, पेअर ऑफ इलेक्ट्रॉन वापरले जातात. अँड दस दिस pyrrole will be aromatic sextet, and thus pyrrole shows what is n will be 1. Okay, very similar to that of furan. Just to see here, furan. In furan, how many pi bonds are there? 2. Pi electrons will be 4. But furan having a oxygen, okay. But oxygen having how many pair of electron? 2 pair, means 4 electrons are there. Just to watch here. Here. Now this oxygen having 2 pair of electron. But this oxygen, to form the aromatic sextet, how much electrons are required? Only 2 electrons are required. Because already there are 2 plus 2, 4 electrons are there. 2 electrons are needed to complete the aromatic sextet. So this furan compound does not use all these electrons, but it uses only 2 electrons. Which electrons it uses? It uses this red color electron, which I have shown here by red color. Okay. So by using these 2 electrons shown by the red color, the furan forms stable compound, stability. That stability is called as aromatic sextet stability due to involvement of this 2 plus 2 and 2 red electron, that is 6 electron. And thus furan shows aromatic sextet, pi electron 6, n is equal to 1. If a question is asked to you in exam, how much electrons is used by the furan to form the aromatic sextet, that is 2 electrons, or you can call it as a pair of electron, 1 pair of electron. Just I will show here another molecule, thiophene, similar to that of oxygen. Sulfur is there, but sulfur having 2 couple of electron, 2 pair of electron, but it uses only single pair, similar to that of oxygen. I think there is no need to discuss again, same thing is. So just you shift to cyclopropenyl anion. Similar to that of aromatic sextet, aromatic duet is there. Aromatic duet means 2 electrons, only 2 electrons. Just you see here cyclopropenyl anion, here positive charge is there. This bond shift to here, again positive charge is here. Okay, now this bond shifts here, again positive charge is here. On this cyclopropene ring, positive charge shifts from one position to another, second position to third position. This positive charge continuously rotates, delocalizes, moves from one corner to another corner, moves from one carbon to another carbon, second carbon to third carbon. And that cyclopropenyl anion have stability. There are 2 stabilities. One molecule which having sextet is stable. Another molecule which having duet means 2 electrons, that are also stable. Okay, so cyclopropenyl anion having how much electrons, how much pi electrons? Only 2, and that's why cyclopropenyl anion is also stable. If you put the value of 4n plus 2 is equal to 2, what will be there? N is equal to 0, n is equal to 0. So 0 is integer number, non-negative number, and so if n is equal to 0, or n is equal to 0, 1, 2, 3, 4, 5, 6, whatever it may be. If n, the value of n is 0 or whatever it may be, but it should be integer, that type of organic compound obeys Huckel rule. And if Huckel rule is obeyed, then molecule are stable, aromatic or stable. If you calculate this pyridine, imidazole, oxazole, you can try at your home how the aromatic sextet is formed, and they shows or they follow the Huckel rule. Just I will show another same. I have here two pi electrons. It is aromatic. Now this is a cyclo butadiene. Buta, one, two, three, four corners are there. At each carbon, one carbon is there. At each corner, one carbon is there. How many carbons are there? Four. So we are calling buta for four. So why the ene butadiene? Di for two double bond. Ene for alkene. So the name of this compound is cyclobutadiene. So how much pi bonds? Two pi bonds. Pi electrons are four. Okay. 4n plus 2 is equal to 4. So when if you solve this, it will be 1/2. Okay, it will be value of n is equal to half. So this is not a aromatic compound. So I have shown here not aromatic. Okay, so this cyclobutadiene is not aromatic, or you can call it as anti-aromatic, opposed to that of aromatic, anti-aromatic or not aromatic. So this is benzene. Earlier I have discussed with you that. So this is how much corners are there? 8, you know, 8, right, octa. How much double bonds are there? 4. So the name of this compound is cycloocta tetrene. Tetrene means 1, 2, 3, 4. 4 double bonds. So tetrene, ene for double bond, tetra for 4. Cyclooctatetrene. Okay. How much bonds? 4 pi bonds, 8 pi electrons. So not aromatic. Again, 10 pi electrons is there. This is azulene compound. Azulene. So 10 pi electrons. So 4n plus 2 is equal to 10. 4n is equal to whatever it may be. The compound is fully aromatic. If you check, the question may be asked in your exam. Decide on the basis of Huckel rule, the given compound is aromatic, non-aromatic, or anti-aromatic. The question may be like this. So you can decide on the basis of Huckel. So this is another cyclopentadiene cation. 4 pi electrons are there, and these 4 pi electrons containing organic compound are not aromatic. Already I have discussed in case of cyclobutadiene. This is anion, but it is not anion. So question is here, using the criteria for aromaticity, determine if the following molecules are aromatic. You check all these are compounds and decide either the compound is aromatic or not aromatic. Again, I am repeated here how benzene is called as aromatic on the basis of Huckel rule, how the n value of benzene is comes there in case of 1, n is equal to 1, thus benzene is a aromatic compound. So I will move to next point, very important, that is aromatic electrophilic substitution reaction. In earlier period also, I have discussed with you that benzene does not produces what type of reaction? Addition reaction. But very easily, very quickly, which type of reaction is given by the benzene? Very good. Substitution reaction is produced by the benzene molecule. So as benzene produces very easily substitution reaction, so how substitution reaction is possible? How substitution reaction will be given by the benzene molecule? We will see in next slide. That is aromatic. Just to check the title of that slide is aromatic electrophilic substitution reaction. One by one word I will discuss with you that why the word aromatic. Benzene is aromatic, so the name is aromatic. Okay, this reaction is, we are going to conduct this reaction on which type of compound? On aromatic compound. That's why the word is aromatic. Next word is electrophilic. In this reaction we are bombarding electrophile, E positive, positively charged reagent is bombarding on aromatic compound. So this reaction is called as electrophilic. If there is a nucleophile, you can call it as nucleophile, nucleophile. So aromatic, this reaction is on aromatic compound. This reaction is due to electrophile, that's why electrophilic. Another word is substitution. This reaction is substitution, means if one of the atom or group is removed and another group or atom is substituted, okay, and that's why this reaction is called as a substitution. Okay, are you clear? Aromatic, electrophilic, substitution reaction. Okay, in this, if you check the name of these aromatic, what is meant by aromatic, why the name is electrophilic, why the name is substitution, this is, this suggests a lot to you regarding the regarding this aromatic electrophilic substitution reaction. Earlier I have discussed with you that benzene has a pi electron, okay, which forms the cloud, which cloud is present at the above side of the plane as well as below side of the plane. Okay, this is just like a frame. Frame means when you, जसं आपण एक जाळं बनल्यासारखं होतं, this is as like a net which is present at the above as well as below side of the benzene. So the cloud is there, just in the cloud, monsoon cloud is there, this cloud is filled with water, okay, filled with water. Similar to that of benzene forms the cloud but not of water. The cloud is filled of, very good, pi electrons, very good, filled with pi electrons. The pi electrons cloud is there. These all just like a network, just like a cloud, just like a bunch of electrons present at the above side of the plane as well as below side of the plane. So electron means what type of charge?